All right, we're going to talk a little bit about acid-base reactions. And before we get into the actual reactions themselves, we need to look at strong acids and strong bases versus weak acids and weak bases. So the first thing that you need to know is you need to know what the strong acids are, and you need to know what the strong bases are. So here are our strong acids. We have hydrochloric acid, hydrobromic acid, excuse me, sulfuric acid, nitric acid, hydroiodic acid, and perchloric acid. For the strong bases, we have lithium, sodium, and potassium hydroxide. Those are all group 1 metals, and then we have 3 group 2 metals, calcium, strontium, and barium hydroxides. So, you need to memorize all of these and put these into your head in order to do well at acid-base reactions. So, first of all, let's look at what happens when you put a strong acid like hydrochloric acid into water. Well, what happens is that it completely breaks apart into its ions. So if you started off with like a 0.5 molar solution of hydrochloric acid, you're going to get 0.5 molar hydrogen ions, and you're going to get 0.5 molar chloride ions. And this reaction occurs, it goes to 100% completion. For a weak acid, for instance, let's look at like hydrofluoric acid. So when you put this in water, all right, you are going to get some hydrogen ions and you are going to get some fluoride ions, but it's not going to be very much. And so basically, you're going to have all 3 of these as aqueous. So you're going to have the molecule hydrogen fluoride, and then you're going to get some hydrogen ions and some fluoride ions. So if you started off with a 0.1 molar solution of this, you might end up with 0.01 molar hydrogen ions and 0.01 molar fluoride ions. So about 1% of it will ionize. And if you'll notice, this has the arrow pointing both ways for the reaction. So this does not completely deionize like the strong acids where the arrow is only pointed in one direction. For a strong base, if you look at these strong bases are typically ionic solids, and when you put a strong base in water, once again you get 100% dissociation. So if you had a 0.25 molar solution of sodium hydroxide, you would have 0.25 molar sodium ions, and you would have 0.25 molar hydroxide ions. Now, weak bases are much different than the strong bases. For weak bases, and the biggest example of that is ammonia, is weak bases react with water, and what they do is they take one of the hydrogens from water, and you will get an ammonium ion plus the hydroxide ion. And that's much different than how the hydroxide ions are produced with the strong acids. Here's another example of a weak base. We have what's called methylamine, and it's going to react with water, and one of the hydrogens from water is going to get transferred over to the methylamine, and that's going to make the methylamine positive, plus you're going to get this hydroxide ion. So if you know the strong bases and weak bases, you can predict how these are going to react when they're placed into water. Alright, so let's look at the three main types of acid-base reactions. And the first type that we're going to look at is with a strong acid and a, sorry I can't spell, a strong base. So let's look at a molecular equation first. So we have hydrochloric acid plus sodium hydroxide produces sodium chloride plus water. So if we look at a total ionic equation, since these are strong acids and bases, our strong acid completely dissociates to hydrogen and chloride ions. Here we get sodium and hydroxide ions. On our reactant side, we'll have sodium ions plus chloride ions plus water. So if we mark out our spectator ions, we're going to get rid of the sodiums, we're going to get rid of the chlorides, and so for our net ionic equation, what we're going to be left with is hydrogen ions plus hydroxide ions produce water. And this reaction right here, anytime that you have a strong acid and a strong base, this is the reaction that you're going to get. Because with the strong acid, whatever the hydrogen ion, whatever ion it's bonded to, it's going to be a spectator. For the hydroxide ion, whatever the positive ion is here, sodium, potassium, calcium, strontium, it's going to be a spectator ion too. So this is the easiest kind of acid-base reaction to write, because if it's strong acid, strong base, it's just hydrogen plus hydroxide gives you water. So let's do this reaction. Let's look at hydrofluoric acid plus sodium hydroxide. And let's first do the molecular reaction. So we're going to have sodium fluoride forming plus water. Now, let's look at the ionic equation. So this hydrogen fluoride, because it is a weak acid, is going to exist as this molecule on the reactant side. So you're going to have hydrogen fluoride plus, since this is a strong base, sodium ions plus hydroxide ions to produce sodium ions plus fluoride ions plus water. And let's look at this and cancel out our spectator ions. So sodium is gone. And that's about it. So you end up with a net ionic equation of your hydrofluoric acid plus hydroxide ions produces, oops, sorry, there's my arrow, fluoride ions plus water. And so it's going to give you a general formula of your weak acid plus hydroxide ions will produce, this H will go over here, and you will get water plus whatever the negative ion is in your weak acid. So this is the general reaction for a weak acid plus a strong base. Alright, so let's look at our third type of acid-base reaction. We have a strong acid and a weak base. So we have nitric acid, which is a strong acid, plus ammonia, which is a weak base. And so what happens is this hydrogen is going to transfer to our ammonia, and we're going to get nitrate ions plus ammonium ions. Now, if we look at this, since this is a strong acid, it's going to be hydrogen ions plus nitrate ions plus ammonia reacts to produce nitrate ions plus ammonium ions. So if we cross out our spectator ions on both sides, we end up with a net ionic equation of hydrogen ions plus ammonia produces ammonium. And so the general equation for this, for our strong acid, it's always going to exist as hydrogen ions plus our weak base, and it is going to produce, this hydrogen is going to bond to our weak base, and we're going to end up with a weak base with a charge of +1. Well, the hydrogen bonds to it like this. And this is our net ionic equation for those reactions. So these are the three basic types of acid-base reactions. And if you know these three basic types, it's going to save you a lot of time and effort when you are looking at how acids and bases react with each other.